So we're not going to talk about the syllabus. See, I used to spend time in the first class like reading some of the highlights. It's incredibly boring for everybody. So we're just going to skip over this. There is lots of good information, required reading. Part of your homework tonight is going to be to read through the syllabus and bring back any questions that you might have. But let's go ahead and start at this very early point in the class. Any questions about what this class is, or policies or procedures? Anything at all? Yes. Attendance policy, good question. Attendance counts for some of your grades. So let me pull it up. Oh, we should turn this guy on. So let's scroll ahead to the attendance section, right down here. Okay, so I think this is like page 4 or something like that. We see it? It's not the last page, but it's the one before. Course grade. It says that participation is 7% of your grade. I have no required attendance policy, but if you aren't here, you cannot participate. So this is my way of rewarding, not just showing up like a blank slate, but showing up and participating and working with your neighbors who you will become friends with. So it's not required, but it's there as part of your grade. Other questions? Do I use a microphone? Yes, I am recording this class, and on Monday, I will tell you how to access what I am recording right now. Good question. Other questions? Okay, so then let's just talk real quick about the textbook. You will find copies of the old edition and new edition of our book over in the Math Studio, which is right across the hall here, right through these glass walls. In the bookshelf on the bottom, you will find Math 117 on the side of some of those books. Just be sure you know whether you're looking at the old edition or new edition. They're both over there. There's also a copy of the new edition on reserve in the library. So regardless of what you decide to do with the book, even if it means you're not going to have the book for the next week or two, there's no reason for you not to be able to do your homework, right? This book exists free over here to borrow in the Math Studio, free in the library to use in the library. Any questions about any of that? Okay, so that is that. The other handout, and a couple of folks came in just a little bit late, so make sure you have 2 handouts. One of them is a big packet and one of them is a syllabus. So one of these here, there you go. Do you have both? Great. And here you go. Everybody has both? Super. Okay, so the big packet. I'm not going to hand you a big packet every class. That big packet covers roughly the first third of the semester. So about a month from now, I'll give you another big packet and then one more in November, okay? So pretty much these are the only handouts you're going to be having, you will get from me for about a month. So the big packet is what we'll be using every day in class. There are a bunch of reference sheets on the first few pages. We're going to start on page 10, and then we'll come back and talk about the reference sheets as we get to them. But if you could jump to page 10, that's where we begin here.
Will conclude the talk with voting by exploring the called areas of possibility. Let's start by taking a look at a PDF to see what can go wrong with voting.
Okay, thank you so much. So before we check out that PDF, I want to highlight one thing. It's on the very back of the syllabus. This document that I'm projecting is on the back of the syllabus, which was that small packet. And this tells you exactly what we are covering today. So I've highlighted it here in the first row. It's September 4th. This next column tells you the class number. I'll show you where to find those, but I've numbered all the classes to make them easy to find. In your textbook, new edition of the textbook, we cover sections 1.1, 1.2, and 1.3. That is what we're doing today. It is all about voting, in particular, 2 things called the plurality and Boredom methods. We'll learn about them today. There's a little bit of info here about projects. We'll talk about them later today as well. But this gives you a very good sense of where we are and where we're headed. And if you ever miss a class, there's no reason to not know exactly what we did in that class and what homework is due. All right? So that document is one that will hopefully help you throughout the semester. You have it on the syllabus. Okay, so the PDF that we just heard reference to is this one. Before I pull it up, there are going to be 10 people that are going to go on vacation. All 10 of them are going to exactly the same place, so they're going to have a vote to decide where they go, okay? And the choices are, well, you'll see the choices here. So take a look at the results of the vote. The 3 people on the far left, where do they want to go? Hawaii, sounds lovely. The 3 people in the back? Florida, wonderful. The 4 people on the right, South Pole. Where are these 10 people going to go if they just follow the results of this election? South Pole. Is that fair? 4 beats 3 and 4 beats 3, right? South Pole takes it. What's not fair about this? So when you say majority, what do you see up here that says South Pole is not the majority? It's only 4 out of 10. So it's not more than half the people. It's less than half the people want to go to the South Pole. Other thoughts? What's not fair? Hawaii and Florida tie at 3 and 3. And there's some commonality between those people, right? The people who want to go to Hawaii would probably be pretty okay going to Florida as well, and not so much the South Pole. And the same thing for the other direction, right? You've got these 6 people that clearly are dressed for some warm climate, beaches, oceans, all that good stuff, and 4 people bundled up. So if we're just looking at like the general will of the people, 6 of them want to go to someplace warm, but where are they going to go if we just go with the way we generally hold most elections here? They're going to the South Pole because everybody just gets to vote for their top choice. 4 people is more than any other choice that got some votes here. So this is an example of what can go wrong. We take voting for granted, that it's just like, oh, you vote and then whoever has the most wins. But funny things like this can happen. And so that's what we're talking about in the first few classes here of the semester. Number 2, can you read number 2, please?
We introduced the mathematics of voting with a tasty sample drink, following flavors of ice cream: vanilla, food, chocolate, tea, strawberry, apple.
So go ahead and write V, C, and S in some order. Your choice, no peeking. I was looking at somebody else's. Okay, everybody have theirs filled in? Okay, number 3. Would you read for us, please?
Now our job is to determine which flavors win.
Plurality.
Where the winner is the most first place votes.
Plurality.
Plurality.
Yes, so plurality candidate, just the candidate with the most first place votes. In the vacation election, we only saw first place votes. Who got the most first place votes in that picture? South Pole. They had 4, which was more than 3 and 3. So all we're going to do is count how many first place votes each flavor got. Raise your hand if vanilla is your first choice. Nice and high. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to count myself as 10. Raise your hand if chocolate is your first choice. 1, 2, 3. Raise your hand if strawberry was your first choice. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Again, we are looking for the plurality candidate. It's a hard word to say. Who got the most first place votes? Vanilla. Vanilla is our winner, straight up, and that's it. Okay. So plurality only looks at your first choice. Okay, moving on to number 4. Can we start here? Number 4, please. Okay, so new vocabulary word, and we actually heard this young man talk about majority before. So majority means more than half, more than half. So did we have a majority candidate in the ice cream example? Well, I needed to calculate something before I can figure out if vanilla got more than half. What do I need to calculate? Total votes, right? In order to know half, we got to know half of what? So how many people voted in our election? 21 total votes. How much is half of 21, even though it's a decimal? Give me the decimal. 10.5 is half, yes? So if somebody's going to have a majority, they must have more than half. Not half, more than half. So majority would be, majority is more than 10.5. That 0.5 is kind of silly, so basically 11 or more would be that majority, right? Was there a majority candidate in our election? No, didn't quite. Vanilla didn't quite have more than half the votes. If one more person had swapped over to vanilla, then vanilla would have 11. That would have been a majority. So this happens pretty often, where the winner of an election doesn't have more than half the votes. That's okay. So an important distinction between plurality and majority. Majority means more than half. Plurality means more than anybody else. Say it again. Majority means more than half. Plurality means more than anybody else. Okay? Which one of those is a stronger thing? Is majority. If you have more than half, automatically you have more than anybody else, right? You can't have two people that have more than half. But weaker, but still maybe enough to win, is a plurality, like in that South Pole example. They didn't have more than half of the 10 votes. They only had 4 out of the 10. But a weaker condition, they had more than anybody else. They were a plurality candidate, okay? All right, so I think we've already answered this next question. How many votes are required to have a majority in this class with our 21 voters? We needed 11. 11 or more in this class. Okay, same question now. How many votes are required to have a majority in a class with 49 students? 49 students. So we need more than half. Go ahead. 24 and a half would be exactly half. We need more than half, so 25. Yes? So 24.6 would take it. We're going to say 25 or more is this first one. More than half. What about in a class with 50? It's 26. Because you start always by doing half. Half of 50 is 25. You need more than half. Half is not going to cut it for the definition of majority. So 26 or more. Any questions on the process of finding how many you need for a majority? Okay, more than half. We'll go to number 5. Can we go here in the middle? Mm-hmm. Great, thank you. So when we found the winner of our ice cream election was vanilla, we didn't pay attention to all of the different preferences you guys had. What was the only thing I asked you to weigh in on? Is your first place choice. I didn't ask you what your second was, and I didn't ask you what your third was, right? Those numbers are not included in the 1038 up here in blue. We were only looking at first place votes. So now what we're going to do is, so we've just heard a definition here. You guys filled out a preference ballot when you ranked vanilla, chocolate, and strawberry in some order. It's a ballot, you know, you go to vote and you fill out a ballot, but you listed all of your preferences. So it's called a preference ballot. And now what we're going to do here in 6 is tally everyone's preference ballots. Those are your individual preferences in something called a preference schedule, which is going to be a nice way to encapsulate all of the information that you guys voted with. So one of these columns represents your preference. For example, this first column right here are the folks who thought that chocolate was their first choice and vanilla was their second choice and strawberry was their third choice. Take a moment, figure out which column you are and circle it. One of those columns represents your preferences. Everybody find theirs? Okay, so what I'd like to do now is figure out how many people are in each column. So if this first column was you, raise your hand. 1, 2, 3, and 4. We got everybody? Okay, second column, raise your hand. Chocolate, strawberry, vanilla. 0. Third column, vanilla, chocolate, strawberry. 1, 2, 3, 4, 5. Fourth column, vanilla, strawberry, chocolate. 1, 2, 3, and 4. This is the right answer, by the way. Fifth column, strawberry, chocolate, vanilla. 1, 2, and 3, 4 here. Good. And then last column, strawberry, vanilla, chocolate. 1, 2, 3, and 4. What would be a quick check to make sure that we got everybody? Something is funny. Yeah, the total here should be what? Should be 21. What is our total now? It is 21.
Whether people put chocolate first, it was 3 and now it's 4.
That's interesting. Yeah. So everybody's up here, but somebody's in the wrong column. So let's see. So it must be one of these folks that have chocolate or vanilla first. So just double check. If you're a strawberry person, you're in the clear. You did good. But if you're in one of those first 4 columns, just make sure that you circled the right one, because we want to make sure this agrees with what we did up above. So it's this one, vanilla. This one here. There's some voter anomalies happening here. There's some funny business going on. Okay, all right, so we figured it out. So this doesn't quite agree with what we had up above because there's some shenanigans in the back corner. But let's just go with this one as it is. So this is called what? That is a preference schedule. You filled out a preference ballot, that's 1. This is a preference schedule, that's all of us. And you know what? This is a really concise way, a really compact way to record everything there is to know about you guys. Every one of you is up here, and all of your preferences for vanilla, chocolate, and strawberry are in this little table, which is kind of nice. Because if I tried to list everybody I could have like 21 different columns if I didn't group you together, right? But we grouped them together, and to be honest, if there's a 0, you don't even put it, so like that wouldn't even appear in the table. And we've got everything. Everything there's to know about you guys and your ice cream preferences is right there in that little table. Okay, it says we're going to look at highlights of the syllabus. I've decided not to. Any other questions about policy procedure stuff at this early stage? Okay, less syllabus means more math, which means everybody wins. Let's move to the next page. Number 8, could you read for us, please? Okay, so these folks are all listed by first initial only. And this collection right here, is it a preference ballot or preference schedule? That is a schedule, it's everybody. And so let's see if we can answer some of these questions together. How many voters in total? Talk with your neighbors, see if you can figure out how to calculate how many voters. Actually talk out loud with your neighbors and see. And once you've done the calculation, double check with other folks. All right, I've heard 1 vote for 37, is that right? One table's got 37? Yep, good. Okay, 37, add them all up right across the top row. Next question, how many votes needed to get a majority? Talk with your neighbors and write a number in there, please. Okay, how many votes needed? Is it 18 or 19? 19, right? We cut that in half, we get 18.5. We need to go up from that. So 19 or more. Super. Next part says, who wins the election using the plurality method? And we're going to show our calculations together. So some of you right now, I'm sure, can figure out exactly how to do this, but we're going to do this together as a group. And I promise you'll have plenty of time today to practice this with your neighbors. But in terms of looking for the winner, let me show you a very common wrong way to do this. Very common wrong way. How many columns have A as the first choice? How many columns? 1. How many columns have C as the first choice? 2. It is very easy to look up here and say, oh, C beats A because C is there twice and A is only there once. But what does that not take into account? It's the number of first place votes. That first column for A, sure, it's only 1 column, but how many people are compressed into that column? There's 14. There's a lot of people in that 1 column, okay? So it's very easy when you're first playing around with the preference schedules to ignore those numbers up there, and it's very wrong to do that too. So let's start calculating here. So we're just going to write down first place votes for A, B, C, and D. One more time, how many columns has A in first place? Just the one. How many people are in that column? 14. A has 14 first place votes. Now we're looking for all the columns that have B as the top choice. Just the one column. How many people are there? 4. All right, the winner of this selection is definitely not B. Looking pretty good for A at the moment. Okay, how many columns for C? 2. So we're going to add up those people. I'm certainly not going to expect on a test, like I'm not going to require that you write 10 plus 1, but I'm just putting it here so we're all really clear what we do with those two numbers. I mean, it's 11, right? It's easy to see. C has 11 first place votes. And finally, D, how many columns? Just the one. How many people there? 8. Super. 14, 4, 11, and 8. Who wins this election? Nobody wins? Well, that's the question. Do we need a majority, or are we content with just a plurality, which is more than anybody else? So I will tell you that we're going to have a few different ways to count the votes, but the only one that we have right now is called the plurality method. All that we require is a plurality. We don't need more than half. We just need more than anybody else. So A wins. Definitely A didn't have the 19 required for a majority, but another good prize. They had more than anybody else, so they win. Okay, part D, the gentleman in the Florida shirt. Okay, so maybe we don't want to know just who wins, but we want to know how everybody did relative to each other. So we're going to list here all the different positions, first, second, third, and fourth. And you guys look so smart that I bet without any instruction from me, you can write down the correct letters there, A, B, C, and D, put them in the right spots. Go ahead. Easy, right? Who's first? All right, so A is first. We knew that before. Who's second? Is C with 11 votes. Third is D has 8. And then last place, B has only 4. That is called the complete ranking, right? Not just looking for first choice, but look for all of them. It is very natural to do. Okay, moving on to number 9. We'll go here in the purple. Great, thank you. We'll move around the table. Okay, so let's talk very specifically. I'm just going to go back here to our ice cream example. Okay, so who was the big winner with the ice cream? Vanilla was the big winner. But there was another candidate that was pretty close. Who was that? Strawberry. Let's look at the 3 folks that are chocolate fans. Raise your hand if you're one of the 3 where chocolate was first. Do you prefer vanilla or strawberry? Yeah, vanilla or strawberry. Vanilla. Okay, all 3 of these folks are relatively happy with what happened, right? They didn't get chocolate, but their second best choice was vanilla, and that's what they got. But what if all 3 of these folks had said, you know what, I really hate I hate vanilla, and I really want strawberry to win. What could these 3 people do? Couldn't they switch their vote for strawberry? Like if we took these 3 people, if they somehow had like this divine intervention and they knew what was going to happen beforehand and they knew their beloved flavor of chocolate had no hope of winning this election, then maybe they say, oh, we're going to take our 3 votes. We're not going to give them to chocolate because that's going to lose anyway. And we're going to send them over here and change the outcome of the election. That is called insincere voting or tactical voting because they're not voting with their heart, right? But they could get a better outcome by not voting with their heart. That's one of the weaknesses of plurality elections, is that it can lead to this kind of thing. Every 4 years we elect a president. There might be a dozen people listed on the ballot, but really how many people have a chance of winning in any given election? 2, right? And we don't know who's going to run this in 2016, but we can tell you that either a Democrat or a Republican is going to win, and the other 10 people on the ballot have absolutely no hope of winning. So even if you think that the Green Party is the most fantastic thing ever, a lot of people would say, well, I'm not going to vote for the Green Party because they're not going to win. And probably most of the folks who are green are more Democrat than Republican and just might throw their votes to the Democrat because they know the Green Party candidate has no chance of winning. That, to me, this is my opinion now, that seems somewhat less than ideal, where you can get a better outcome by not voting with your gut, right? I want people to go out there and vote the way they feel and not get a better outcome by voting with some strategic thing in mind. Okay, let's come back down to here. Where are we now? Number 10. We'll go around the table here. Okay, that question right there is a very standard test question on my tests. So let's make sure we can answer this one together. Again, who was the winner of the election? A. We are looking for people who would prefer somebody else other than A. So in terms of folks maybe changing their minds, which column was already happy? Which column was already happy with what happened? The A column. So these folks aren't going to vote strategically. They got what they wanted, right? So we're not even going to look at them. Okay, let's look at some other folks. How about B? B was last place. There are 4 people that voted for B. It would take a lot of change for B to get enough votes to pass the 14 that A has, right? B is kind of a long shot. And D is also kind of far away. So I'm going to focus my attention on C, which is a second place vote, and see if we can somehow manipulate this election and change it so that C is our winner. So the people that already voted C, we don't want them to do anything different. We want C to already have the 11 that it had, plus some more. So we're going to cross off these guys, and we're going to cross off these guys. And we're just going to look at the 2 columns that are still in play, right? These are kind of the swing voters. Okay, so would either of these folks, either the first column or the second column, would they prefer C win this election instead of A?
Yeah.
Yes. One or both columns would prefer C to A. They would both prefer C to A, right? This first column right here, okay, yeah, they thought D was the best, but they thought C was second best, and they put A dead last. They really would like to avoid A coming through and winning this election. Same thing here in this column. They thought B was the best. B didn't win. They thought D was second best. D has no chance at the moment. But at least they'd rather have C than A, all right? So either of these 2 columns would be quite happy to change the outcome of the election. They don't want A. A is the worst candidate in the world in their opinion. So they'd like to do something maybe to finagle it so that C becomes the winner. Okay, all we need to do is find some votes. How many votes do we need for C to pass A? We want them to pass. 4, right? If we just find 4 votes, put them in C's ballot, then C wins. So for example, if these 4 people just change, and let's put, maybe we'll put C first. That's going to be enough to do it. Probably if they're still voting with their hearts after cheating a little bit, they still think B is the best, so they'll put them second maybe, and maybe D first, whatever. Just keep A at the bottom, that's fine. And now how many first place votes does C have? C has 15, and C has just won the election. So it's a little bit of a process, a little bit of work to figure out how to change the outcome of the election, but there's a method to it. So let's just write in here, the 4 folks who voted, what was the order for that column? B, D, C, A, thank you. They could instead vote for which one first? C, that's all that we need. You could fill in anything you want over here. I mean, I suspect that these people are going to keep the relative order that they did before, but really all you got to do is move C up to the first spot. And if those 4 votes shuffle the votes around, Then who wins? C wins. Not A. Questions on that? That's the hardest question we've answered so far today, but it's one that I'd like you to be able to do. So with some practice, you can kind of follow the plan that we did up above and just change a preference schedule so that the outcome of the election changes. Okay, we're going to skip over 11, but you can read through it later on. It talks about compromise voting. It is not ideal. We'll move on to number 12, please.
It's called the
Borda.
Boredom Method. This is the 8 college people rank their top for each candidate points. We will calculate one the last place vote, 2 points for the next last place vote.
Great. And can we go to the back corner by the table? Yes. Could you read that last part, please? Great. So it's just a point system. Last place is always going to be worth 1 point. That's how we can start. Last place is 1. Next to last place is 2, and you work your way up. So if you have 4 candidates, then the first place votes are 4 points, right? 5 candidates, first place votes are now worth 5 points. So let's take a look at our math club election preference schedule again. Here it is. And we're going to go ahead and use the board account to determine the winner, or at least we'll do part of the calculation. It turns out the calculations are pretty tedious, but once we've done, say, 1 or 2, that's probably sufficient. So let's go ahead and take a look at A. So we're going to look at first place votes for A. How many first place votes did A have? It had 14. So we're going to circle for A here, 14. And then each first place vote is worth how many? Is worth 4. 4 candidates, 4 points each. Are you guys buying 14 times 4? That's how many points A is going to get. All right, so we got 56 from those points. Makes sense, right? Each person that thought A was the best gives A 4 points. There were 14 of those people. Okay, let's keep going with A. And I'm going to put a plus sign because we're just totaling up points. And now we're going to find A second place votes. How many second place votes did A have? None. So I'm just going to go ahead and write it just so we can see the whole pattern, but A had 0 of those. And technically we should multiply by 3, right? Second place votes are worth 3 points. Okay, moving right along, looking for third place votes for A. How many third place votes did A have? 0. A is a very polarizing candidate, right? You either love A or you hate A, and there's nothing in between. Times how many? Those are 2 points each. Okay, now finally we're going to find lots of A's. So we're looking for how many A's there are in the last row.
4.
And it's very easy to say 4. Yes, there are 4 columns, but we're looking for how many voters there were that put A last. And so we're going to have to add those 10 people and these 8 people. I heard a couple of 23s. So we add all of these up, 23, is that right? Okay, great. Right. Okay, 23 voters, and how many points is a last place vote worth? Just 1. Last place will always start with 1 point. And so we do our calculations and we add them up and we'll get a total for A, and this will be it. 6, 23, that's 79. 79 points. We're going to do one more in this election. But before we do, can you at least admit that there's something desirable about looking at everybody's votes? You're not just looking at first place votes, right? We looked at how everybody felt. And until we did that, we actually didn't realize how many people hated A. Yes? It became very clear when we started looking for A in the second row. Oh gosh, nobody thinks A is second best. Oh gosh, nobody thinks A is even third best. We had no reason to look down here before when we were only looking at first place votes. But this method, okay, it's got its flaws. But at the very least, it looks at how everybody feels about A and how everybody feels about every candidate. So that seems like something good, something better than the plurality method does. Okay, we're going to skip over B. I'm going to jump to C. So let's try C. Same idea as before. Can you guys take a moment with your neighbors, see if you can help each other out and get the total for C? Yeah, so who wins this if we're doing the Boredom method? Who has the most points? Is B, right, with 106. B has 106 points. Did B win when we did just the plurality before? No, A was the winner. Was B in second place before? B wasn't even in second place before. But somehow, by looking at everybody's preferences, B leaped ahead. I mean, you can kind of see it actually. Well, you guys didn't do B. I did B. But if you take a look at B, there's a bunch of B's here, and there's a bunch of B's here. And there's even a B up there. Where is there no B? At the bottom. Nobody hates B. So everybody gave B some points, whereas A got like hardly anything for most of the people in this election. So it's kind of surprising maybe that we don't have the same winner looking at these two different methods. Okay, so I know you guys didn't do B and you didn't do D, but we've got the numbers up here. Can you guys do the complete ranking? I think it's down here in part C. I can't project both, but the complete ranking. We already know who first place is. Can you write down who's first, who's second, who's third, and who's fourth, just using Boredom points? Okay, so we're just going to abbreviate the answer here. First place was B. Oops. Second place is C. So we go B, and then C, and then D, and then A. Really surprising, because A was the winner of our plurality election, but dead last in the Boredom method. How come? What did we see in the preference schedule? And more than just they didn't vote for A. Where did they put A? Everybody put A last except for that one column, right? It's really surprising, from first to last. Okay, there is a little check. I'm here in part B. There is a little check that you can do to make sure that you did everything right. I'm not going to talk about why this works, but there's a lot of places to make a mistake, right? There's nothing hard in this calculation, but there's so much arithmetic and so many numbers that are written down. It's very easy to make a mistake. So here's what I'm going to say. If you have a calculator handy, just go ahead and add up the total points for each of these candidates: 79, 106, 104, and 81. So just add those all up. I'll keep it up here on the board. And for folks who aren't typing anything in, I'll say this. Here's the check. Did we do how many voters? Do we know how many voters there were altogether? How many were there in this one? Is this one 37? Yes? Okay, so people with the calculator, don't say the answer out loud yet, but I'll just say what the check is. If we did this right, then the total Boredom points for 4 candidates, I'm only giving you something that's going to work with 4 candidates, should be the number of voters times 10. Number of voters times 10. Without any justification. Just putting it up there, it should be a mystery at this point. How many voters did we have in our case? So 37 multiplied by this mysterious number 10, we get 370. People with the calculators, what did you get when you added those 4 sets of Boredom points? 370. If we had made a mistake, then maybe on the calculator you get 363, and you say, oh, something's wrong. Needs to be 370. And in fact, you can shuffle, I'll bring that back in just a second, but you can have these people change their minds and they can all just vote differently than how they're voting right now. And I can tell you without doing any of these border calculations, total is going to be 370. It's automatic. If you're interested in why it's times 10, I can tell you after class. For another election, if there's 5 candidates, it's times 15. It's just weird, but I'm happy to explain later on if you want. Anyway, that's a check. Okay. Boredom Method, there's a little bit of history here in 14. Our reader is in the back. Go ahead. Okay, so the Boredom winner was B. Who was the plurality winner? A. No. Big no. A went from first to last.
The reason why you vote by number of voters times 10 points ranking vote, right? The first case is 4, but 1. So one person theoretically cast 10 points votes, right? And then find that voter.
Buy it? What's your name? Chad. Everybody hear what Chad said? You vote for first place, you're giving them 4 points. And you're giving somebody else 3 and somebody else 2 and somebody else 1. So altogether it's 10 points. So as a voter, you are awarding 10 points to these candidates. And every one of these 37 voters is awarding 10 points to the candidates. Good. Yes. 6 candidates. 6 plus 5 plus 4 plus 3 plus 2 all the way down is 21 points times 21. Good. Well done. Okay, so moving on to 14, gentleman in blue again, 14. Okay, thank you very much. Napoleon was not a fan of the board account method, and he had a lot of power at that time. Said, we're not doing this anymore, so he changed it. Okay, so there's information about the projects right here, and we mentioned the projects a little bit in the calendar. So again, this is on the back of your syllabus, but there are 3 projects that you're going to do for this class, and let's just talk briefly about this first one here. Okay, it says, you will conduct an election, draw up a preference schedule summarizing the votes, and figure out the winner of the vote according to each of 4 different voting methods. How many voting methods did we see today? 2, plurality and Boredom. Our next class, we will see the other 2. So that will get us to 4 on Monday. So if we go to the next page, it talks a little bit about the first part, which involves coming up with a topic and 4 options. For example, I said, rank these ice cream flavors, and I gave you 3. You're going to come up with something different, not ice cream, but something of your choosing. And not 3 options, but 4. So I'm just highlighting. Vanilla, chocolate, strawberry is not enough. We want 4 options, some question of your choosing. And I'm willing to spend a little bit of class time having your classmates here vote on your election. You have to do some work between now and Monday if you want to take advantage of this offer. It's fine if you don't. You just need to go out and find 20 random people to conduct your election with. But if you want to do it here in class, you got to do something for me before Monday. I'm willing to print out your ballots and spend some time in class on Monday, collect your ballots and give them back to you in an envelope. But if you want to do that, it is here in bold. You must email me your topic and 4 options at least 3 hours before our class on Monday. That is my email address right there. Please don't send anything to Caitlin. She won't know who you are. Okay. So you're going to send me a question, a topic, with 4 choices. For example, rank the following ice cream flavors: chocolate, strawberry, vanilla, and Rocky Road. All right? Don't do ice cream. Come up with something else. So you're going to email me at least 3 hours before our class on Monday. Everybody clear on that? I will then print out all of your questions. We'll spend a few minutes Monday voting. I'll take them back. I'll cut them all up. I'll give them back to you Wednesday. You'll be ready to go do the rest of the project. Okay? Okay, let's see. So we did that one here. So rank the following. That's fine. And try to do this. Try to construct the ballots so that you don't expect any one choice to receive a majority. Like if you just say, you know, I don't know, how many days long should the weekend be? And your choices are like 7, 6, 5, and 4. Okay, so I'm guessing that everybody's going to say the weekend should be all 7 days, and then 6 will be next, and 5th and 4th. So, so try to pick something where it's not really clear who the winner is going to be. All right. Okay. First group activity is below. We'll spend just a minute before we do this looking at the homework assignment. So if you guys jump ahead a couple of pages briefly to this one right here, page 15. Okay, on page 15 at the top, it says learning objectives after class number 1. This was class number 1. Remember I mentioned all the classes are numbered? Class number 1, that's what we just had. Next class you will see a big number 2. So in here is a list of things that I'd like you to be able to do by the time you come to next class. And hopefully you will be able to do all of these things after spending some time working through the homework and reading the book and getting help in the math studio, free peer tutoring, working with your neighbors. But here are 4 things that I'd like you to be able to do. You have no responsibilities. I'm not going to check you on these 4 things. Some students choose to ignore it. I don't think that's a good idea. I think when you feel like you've gotten what you're supposed to get out of this material today, just run through this list and say, oh, do I know how to create a preference schedule? Yeah, I can do that. Put a little check mark. If there's something you don't know how to do, that represents a hole in your knowledge. Fill it somehow. You are going to read sections 1.1 to 1.3 in the textbook. That's the stuff that we just covered. You are going to read ahead, sections 1.4 and 1.5. Normally the reading assignment is only a read ahead, but for today, because none of you came in prepared and had already read the stuff that we just covered, we're reading behind, but normally it's a read ahead, all right? Your homework is going to be to finish this voting activity that you're about to start with your group mates, but you're not going to turn it in. You are going to send me an email about the first project. We just talked about that. You are going, and there's the description there. And then down here are these 2 different assignments. There's this thing called My Math Lab assignment and this thing called textbook assignment. Caitlin's section of this class is using a piece of software online called My Math Lab. We are using a textbook. So you're going to see both assignments here. You are never going to do that one. You guys are the textbook class. So your assignment is here. There are 6 questions that you are going to answer for me, and you are going to turn in your answers at the beginning of class, and you will put them right in this folder, which will be sitting on your table next time. Okay? Any questions on what the assignment is? Okay, so what I'd like us to do now is the group activity. Now there's a list of some other things to do because it's the first day, but we'll go back to this group activity. Your first task is to introduce yourselves to your neighbors, and then your second task is to get as far as you can on these problems right here. Write their names down, makes it much easier to know who you are talking to.